Pollachi, Tamil Nadu, we, the Department of EEE, feel very glad to invite you all to the ATAL-sponsored 5-day faculty development program on Internet of Things. Actually, this FDP is planned to formally be inaugurated by our beloved principal, Dr. A. Ratnavelu, but unfortunately, he is engaged with some management work, so he will later join with us. On behalf of him, I now invite our head of the department, Dr. A. Senthil Kumar, Senior Professor, who is the driving force for all our activities, to inaugurate this faculty development program formally. Sir, please.
Thank you, Durga. Good morning to everyone. I'm very happy and pleasant to inaugurate this 5-day faculty development program on Internet of Things. So I welcome all the participants across all the states and showing interest towards this Internet of Things FDP conducted by Dr. Mahalingam College of Engineering and Technology. And I thank the AICT officials for sanctioning this FDP. Definitely this is a good move. So now, as per our Prime Minister's vision, we have to make our India an electronic hub and a technology hub. So for that, we teaching community, we have to work towards that and make it possible. So Internet of Things is one such area everyone should concentrate. Actually, when you take Internet of Things area, this is not simple area. It covers almost all the domain of engineering: electronics, software development, embedded system, web page development, database management, data mining, deep learning, artificial intelligence. Whatever you tell, that is a part of the Internet of Things. So definitely, this is an area, upcoming area, is a future of the world. So already a lot of work has been started. Many people are working. Okay. So now our aim is we have to start working towards that, and we have to create a skilled individuals. Meaning our students should be developed as a skilled individual that will in turn will develop our country. So this is the right time. So already we thought of when we applying this course, we thought of conducting in our campus, but fortunately or unfortunately, due to this pandemic, we could not do it in person. So anyway, we are going through online. So this also a win-win situation. Our faculty members have learned a lot of things, online platforms, and way we can teach through online portal. These are all we learned new. So this is one good opportunity. Hope this will definitely enhance this, and entire 5 days program will give you an insight about what is Internet of Things. And we have the participants from 18 states and 125 institutions, totally 200 participants. So all the states are there, all the districts, many of the institutions, 125 institutions is not a small number. So all work together across India, definitely we can do wonder. So even the aim of ATAL also the same. So after completing this course, definitely we will share all the contacts, and we keep on continue working, and we have to develop something. So this ATAL is designed in such a way that this program, IoT program, is designed in such a way to give basic input for the people who are very new to Internet of Things, and already who are working with that, maybe given input how they can go further, where you can do concentrate on research. All these things will be given. Okay, so before going to my session, next session will be my session. Before going to my session, as we are not physically present here, I like to show our college view. as a video. Muthubardi sir, please unshare your slide and I'll go. Muthubardi sir.
Sir.
அது அன்ஷேர் பண்ணிருங்க உங்களுக்கு தான் இந்த
ஓகே ஓகே.
Yeah, this is our college aerial view, just to have a feeling. So please feel everyone are in college in our institution. Okay, I thank you once again. I welcome everyone for this Internet of Things workshop. So I request Durga to brief about the sessions, and I'll again come back to the first session as a keynote address on IoT. Thank you very much. Thank you, everyone.
Thank you, sir, for your wonderful inauguration session. So before starting our session, now I'd like to share some few instructions to the participants. The session timing is between 9:30 to 11, 11:30 to 1 p.m. and 2 to 3:30 p.m. daily. So day-wise link will be shared to you all through the WhatsApp group. You can join online by clicking the link through the MS Teams. So all are requested to join the meeting by 9:20 a.m. Also request you to attend all the sessions. Feedback link will be shared at the end of every session. You need to fill the feedback form. Your response will be taken as attendance for that particular session. So this will be followed for all the sessions in all 5 days. So kindly do this. At the end of the FDP on 5th day, the test will be conducted for all the participants. As per ATAL rules, the participants scoring minimum 60% in the test and having 80% attendance only will be eligible for getting the certificate. So this is mandatory. Please keep this in mind. If you have any doubts and clarification regarding the session, you can post your questions in the chat box. So also you can unmute your mic and you can talk. So thank you for all choosing this 5 days FDP, and we expect the fullest cooperation from all the participants from all 5 days. So now we can start our online session. So I feel very happy to invite Dr. A. Sendil Kumar, Senior Professor, Head, Department of EEE MCT once again to deliver a keynote address on Internet of Things. Please, sir.
Yeah, good morning, everyone. Again, I'm joining for giving a keynote address on Internet of Things. Again, as I mentioned in the inaugural speech, so this is the need of the hour. So IoT definitely is a multidisciplinary technology. So it required all sort of knowledge. You electronics, hardware design, microcontroller design, sensor design, embedded system programming, web page development, PHP development, database management, and data mining, data science, artificial intelligence, machine learning, everything is required. But definitely we cannot be master in all the domain. Actually, even this is a heterogeneous group. You can find people from mechanical, ECE, electrical, IT, computer science, even science also there. So definitely there is a part for everyone in Internet of Things. So this session, I am not go in depth about what is Internet of Things. I'll just give you an introduction how we can use Internet of Things, how you can develop a simple model. Okay, and I want to show where you can concentrate. As if a computer science person, database management or deep learning, artificial intelligence, or connecting cloud and user, all these things. For EC or electronics or electrical person, there is a domain. There is a signal edge connection and field level sensor connection, writing embedded programming, connecting cloud with this. These are all the domain available. So I have planned my session to give you what is Internet of Things. Actually, the people who don't know what is Internet of Things should appreciate the session. Then next session onwards, the experts will go in depth and explain about different domain in detail. Okay, so thank you. I would like to go my session. Is it visible? Hope. Yeah, let us see the definition of Internet of Things. Actually, this I took it from Wikipedia. So, the Internet of Things describes the network of physical objects or things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So, this is Internet of Things. So it covers everything. So the present scenario is the devices range from ordinary household objects to sophisticated industrial tools. All are connected together. So as of now, in 2020, 50 million connected devices are there. We may think that we are not finding out anything in our house or nearby, but it is a true. As of now, 50 billion devices are connected in the internet, and the experts is predicting that by 2025, 1 trillion device will be connected with the internet. So see the massiveness. So actually, the developing the system connecting with the internet is not at all a problem. What is the problem? Where we have to concentrate? Okay. See, this is the current status. The data between 2003 to 2020. So in 2003, world population is 6.3 billion. Connected devices was 500 million. 2010, the 6.8 population, 6.8 billion. Connected devices, 12.5 billion. 15, 7.2 billion population and 25 billion connected device. See, in now 7.6 billion as 2020, 50 billion devices are connected. See the growth of IoT. Definitely, it is the need of the day. And also the data. How much data is shared in the IoT related areas? See, in 2012, zero point 0.9 exabytes per month were shared between all the devices. Actually, 1 exabyte is, you know, that 1 billion gigabyte. So in 2013, it is almost double, 1.6 exabyte. In 2014, it is 2.8 exabyte. 2015, it is 4.7. 16, it is 7.4. Actually, I have data on up to 2017 only. I took it from the website. It is 11.2 exabytes. See how much data is transferred. So actually, in the present scenario, the problem is not developing the IoT. How to handle IoT? How to handle such a massive data available for us? Okay, because present days there is no problem for computing, no problem for storage. Everything is available because of the technology involvement, right? So memory in a individual computers, 1 terabyte memory is not at all a problem. But the thing, how to handle this, how to effectively use this data, that is a problem. So that is why the data science, data mining, artificial intelligence, machine learning, all are come into picture. So if you are not able to handle the data, present the data appropriately, there is no use of having IoT. Okay. So actually there the computer science and IT people have lot of work to do. How to present the data, how to do effectively take the data and convert it into usable information. All these things are required. So this might have give you a fair idea about how the data, how many data are transferred between the devices year on year. Okay, the technology roadmap, if you take it from 2000 to 2020, so initially it was the IoT it was in small level in 2000 to 2010. The RFID tags are used to track the thing and tracking the goods, all these things. Then 2020 it was used for surveillance, security, healthcare, transport, food safety in these things. So their ability of the device located indoors receive a geological signal and keep moving towards 2020, it is used for locating people and everyday objects. So this where the data started exploding, and actually this is comes into ubiquitous positioning. It is part and parcel of everyday life of the people, and now it came up to the level of teleoperation, telepresence, and the ability to monitor and control distant objects. Even our CCTV camera controlled and monitored from different places. These are all development of the IoT. So now the present requirement is we have to effectively use all these things. Technology has evolved, we can do anything, we can connect any device with anything. How effectively we connect, how effectively we interpret data, these are all the matters. So before going to my presentation, I like to present a video to understand how the IoT can be used in day-to-day life. Okay, these are all the applications. You can use it in home, wearables, you can monitor, you can send the signal to wherever you want. Then smart city is a very great opportunity, and grid, smart grid for electrical people. The smart grid is the main thing. We have to properly maintain and manage the power, and industrial internet, industrial IoT, and another great thing is connected car. So in future, we are expecting driverless cars. So all the cars will be connected. They speak each other. They take decision. So there is no need of people to control and all these things. If you just keep the source and destination address, it will go and drop you. It will take decision. All these things, and connected health as well. Health also every in future, every people will be connected with the hospital, like it, we are in ICU. So there is a small change in our health condition. Immediately you will get a input from the doctor or a specialist, and you can immediately understand whether it is good or bad. It will going to happen. And retails also. In the retail segment also, there are very great opportunity for IoT and supply chain. That is already it is functioning, and farming, that is also a big thing. So these are all different application we can concentrate. So one IoT you can split into two domains. One is application side, another one is technology development side. So before going to see IoT, let us see this video. You have some idea. So there is no audio. I think for this video, audio is not required. Huh? Huh? Actually, there is no audio for this video. Just this self-explanatory. Yeah. Hope you have some idea about how IoT can be effectively used different domain. What we have seen is a smart home, how the smart home can be implemented with IoT. So there is a positive as well as negative. We cannot escape from anything. Everything will be tracked. See the uh, implementation of IoT. So this is expected in everywhere. So once it is implemented, definitely everything in the across the world, everything will be connected and everything will be monitored. Maybe it will give very highest safety for the people. But another way, uh, the personal life also will be monitored everywhere. So that is also a thing that we will discuss one by one. The major characteristics of IoT is it is a very large scale. Okay. So the millions and millions of sensors will be connected with the internet so that it will say, send data and handle data, all these things. So we should be able to handle the very large scale and it is a heterogeneity. So we don't know what are all the things to be connected. What are all the things want to speak with another things, right? So that we have to create anything, table, chair, fridge, whatever you think, even water bottle, anything can be connected and it may send some information, it may need some control. So heterogeneity is there. So lot of people are required to develop all these things and pervasivity. So actually this is part and going to be in few years, the IoT will be part and parcel of our life. Now itself, many of the cars having this feature, we can track how the cars are, what is the speed it is going, and what is the problem. Even on the go, your workshop man will understand what is the problem in the car. Immediately, you may be informed that please stop the car, or you can give the advice to do whatever you want. All these things is happening, right? So this will be very massive in future years. Yeah, this is structure of simple IoT. Okay, this is a structure of simple IoT. See, in the IoT, you have three segments. One is this a sensor and embedded part, so which will take a real-time signal from the field. So another part is a controller. So controller will take care of communication between field device and internet. And another thing is a user device, maybe with computer or browser or laptop or mobile. This is a user device. So this is a cloud. So cloud is the mediator between these devices. So now you see this field devices need some microcontroller and it needs some embedded programming to handle the data. Once the data is ready, so some other controller with the internet connectivity need to communicate to the cloud. Cloud is nothing but yes storage. Yeah, participants, please mute your mic. Yeah. Yeah, please. Okay. Yeah, a controller is a controller which can capable to communicate with the cloud storage. So actually, we need some Python, Java, or HTML programming to communicate with the to store the data you want. And these are all the users. Suppose you want to read the data from the field, or you want to send some command to the field devices, you can send the data from these browser, or you can mobile phone you can use, or you can use computer, anything. Okay, so here we need HTML, web browser, PHP, SQL database, or Python, anything. So these are all the things involved in developing the structure of the IoT. Okay, this is a general structure. Here you have four levels. IoT structure is concerned four levels. Stage one is a sensor. Okay, as we seen in the smart home video, there are lot of sensor involved. One is sensor, GPS is one sensor to track whether the people have reached that particular position, or another sensor to detect the fumes, fire, gas, toxic gases, or whether you are present in the room. Okay, so everything to be detected. So there is a possibility of sensor technology also. Even some of the activity we don't have sensor. So we have to develop a sensor, right? So this is a basic level. Stage one, we have to develop a sensor and process the data which is available in the sensor. That is stage one. There's a field level equipment. Next level is a internet gateway. So internet gateway is, already we know that how to connect with the internet, the devices. Okay, and another one is edge device. Edge device is a pre-processing device. The data what is collected from these two stages will be processed at this level. Instead of directly sent to the cloud, we can process it, and only useful information will be sent. Meaning this reduces the traffic, because now the data is massive and enormous. Just like that, if you send all the raw data to the cloud, the traffic will be very high, and the efficiency will be reduced. So instead of directly send the data from stage 2 to stage 4, you can have one edge IoT. Is a pre-processing unit. This will handle all the data, and whenever required, it will dump the data to the cloud. And cloud is actually this is a server, data center. You can store your collected data from the stage 1, and it will be stored there. So the cloud will be available for everyone. So the field device can access, send the data, and read the data. And anybody wants to read the data. Some computer wants to know that. Suppose somebody, you have a field device in India, US, you want to access the data. They can go and access the data center or cloud, access the data. If required, again they will send back the command to the field device. So this is the four major layer. So this layer will give you a flexibility and layered approach to develop the IoT. Yeah. So IoT, there are different levels. IoT level 1, level 2, level 3, level 5, like that, based on the complexity. Just I'll show you what are the different levels, how it will be different. So IoT level 1 system is a single node device that performs sensing and actuation, stores data, and performs the analysis. Actually, here the small level IoT, level 1 IoT doesn't need any cloud operation. They doesn't need to access the cloud, because it wanted to operate locally. Suppose within the industry, we wanted to operate all the monitor and control all the devices. You need not to go to cloud and take back the data, because based on the security, all these things. So here the device will take the data and goes to the database, and some other server inside the institution will take care of the database, and app will control that. So without going to the cloud, we can locally manage. This is a simple IoT system. But complexity is very, very small, and the data involved also very small. And next level is, so for IoT level 2. So here slightly bigger. So if that level 2 IoT system has a single node that performs sensing or actuation and local analysis. Data is stored in the cloud and the application is usually cloud based. The IoT level 2 systems are suitable for solutions where the data involved is big. So suppose if we are not able to handle locally, so definitely we'll go for cloud. So here the sensing device will be there in the local, and database, all other application, everything will be in the cloud. So there are two stages. So like that, there are, based on the complexity, you have multiple levels of thing, but this all purely on the architecture and complexity. So the cloud is a mediator. Basically, cloud is a center point. So you can read and write the data to the cloud. Suppose field devices want to access the data, sensor want to send the data to the cloud, it will go to the cloud. Somebody wants to know what is the data. So you can access the cloud and take the thing. So actually there are a lot of commercial IoT platforms are available. ThingWorks, Microsoft Azure, Google Cloud, IBM Watson, AWS, Cisco, Salesforce, Oracle, ThinkSpeak, 000 Post. So these are all the lot of other things also there. So you can use the web host or ThinkWorks, anything. Some of them are free or some of them are payable. So this can be this is the center point. Okay. So this is just an introduction. So what is the research challenges involved in IoT? So basically, scalability is a major research challenge. So now we are developing all these things, but it is not actually scalable. So we have to make the devices scalable. So suppose you have 3 nodes, simply without doing any change, you should be able to make it as 5 nodes, 10 nodes, and it should be multi-purpose. So that required a lot of research. And another thing is, already as mentioned, the data handling. Handle data, as of now, there are 50 billion devices. So handle data generated by 50 billion devices are very difficult. So we need a lot of research input to reduce the traffic, to increase the efficiency, and so on. Sorry. Next is sorry, reliable coverage. So this is another bigger bottleneck. Actually, we need internet connectivity. Okay, in even India, many villages in India don't have internet connectivity. So if there is no internet connectivity, so it is very difficult for coverage is concerned. So we have to do some research. So if the internet connectivity is not there, we should not leave as such. So we should provide IoT even for farming. In the villages are concerned, farms is a potential area where you can implement your IoT. So there are a lot of research going on how to do reliable coverage. Then another one is move cloud services to edge of the network. It's called as fog computing. So as already I mentioned in the previous slide, sending data to cloud directly from the field device and gateway, we have to introduce some fog device, fog computing device. It will do or trim the data received from the field device, and only useful information, required information will be sent to the cloud, so that speed will be increased, efficiency will be increased, traffic will be reduced. And here also need lot of research. So move cloud, part of the operation will be moved to fog or edge device. Then again, the reduced data to be stored. So processing and storage also, all the raw data should not be stored in the cloud. Again, will yep. Sorry, somebody has presented this. Yeah. Durga, is it visible, my slide?
Yes, sir. Yes.
Okay, okay, sorry. Okay, then reduce the data. Here, we need lot of algorithms to do the processing because we cannot store all the raw data in the cloud. It is dumping without unusable data in the storage also. It is like a waste bin. So we should not have a waste, we should not use our memory as a waste bin. So we should have some algorithm, process the data, and only useful information will be stored, like how we are handling our mobile phones. So mobile phones, we have lot of apps. So initially, what we are doing is when we purchase the mobile phone, we keep updating or installing lot of apps, and after some time we'll realize that many of the things are not required, we are not at all using that apps, so we'll remove it. So that we are doing some process algorithm and do that. So here there is no manual intervention, we need the strong algorithm to handle the data, to store, how to effectively process. That is another thing. Then power consumption problem. So actually, this is very, very important point. Power consumption, when you take a single computer, the power consumption is not a problem. When you take a data center, the data center and cloud storage, it consumes megawatt. It is like a big industry. It is more than a processing industry. So there also the computation, all these things, actually in CMOS circuit is concerned, storage is concerned, the power consumed is directly proportional to the number of activities. So we should have an algorithm to reduce the number of activities, meaning write read operation. So it reduces the power. We need software optimization as well. Okay. So another one is now SDN, software defined network, and NFV based IoT is a 5G network. So again, it is evolving. So we need a lot of research. So these are all the research area. So different people who are involved in that can take any one of the area. You have to work towards that. So ECE, maybe developing the edge device, and computer science or IT interested people can take develop an algorithm, processing, storage related things. Okay, so these are all the area we have to concentrate. And standardization also a challenge here. So here interoperability is a challenge. Actually, if you use one cloud, that cannot be directly changed to another cloud. There are standards, but database. So we need interoperability. It should operate between all the platforms. So standardization is a challenge, but people are working. And heterogeneity of the sensors. Actually, for different parameters, we use different type of sensors. So that is also a challenge. So based on the sensor, we processing nodes, everything will be different. So if there is a standardization possible, so this is a big area in IoT, heterogeneity of the sensors, how to standardize the sensor interface, all these things. And interfaces to cloud services. So interfaces to cloud service also, sorry, server. Interfaces to cloud server also, yeah, big challenge. Standardizing the interface. It is easy to interface cloud server. Standardization. So if you want to work on standardization, these three are major area you can concentrate. And also there are a lot of controversies. These are all the controversies. Privacy. So privacy, actually here we are just transferring data to cloud and receiving the data to cloud and anybody can go and take it. Here the security and privacy is, as of now, it is not that much strong. So that is a question mark. So we have to work in that also, because the industries and other things are connected with the cloud, if there is a process industry or any industry, if there is a lacuna in security and privacy, there is a possibility of a calamity. So that is major issue. People are doing that, but this is a problem. This is, still it is a question mark. Then autonomy and control. This is another thing. Then social control. So political manipulation of data received from different thing and design itself, and environmental impact is another controversy, and influences human moral decision making. Here again is a if everything is connected with an internet sensor, decision making will be taken by the node. So who will take care of that? So actually our decision making process itself reduced. So if introduction of IoT may reduce the human moral decision making, that is the biggest controversy. So there are a lot of criticism and controversies. But we have to work towards that. Not only technical, also we have to work towards this non-technical as well. Privacy, security, autonomy and control. These are all technical challenges or criticisms, and political manipulation, social control, environmental impact, influences moral decision making of human. These are all non-technical criticisms or challenges. So there are a possibility of taking care of these also. Okay. So let me complete my presentation with simple idea about how to develop a IoT for simple lamp control or simple load control. You can see this thing here. I want to control a lamp. Okay, the lamp. So I want to use the Raspberry Pi controller as my controlling unit to control my lamp. Okay, so here Raspberry Pi will be connected with the relay. The relay will turn on or turn off the lamp with the power supply, and as well Raspberry Pi also to facilitate to communicate with your cloud. So cloud, for example, I took 000 web host cloud. So actually the Raspberry Pi controller, we have to write a Python code to read and control the lamp and read the status of the lamp. And also we have to write the Python code to access the PHP code available in the cloud. So PHP in turn will communicate with your database. So database will store the status of this. Suppose some user wants to know the status of the lamp, whether it is glowing or it is in off condition. So by reading the content available in the database, you can access through HTML. So HTML and PHP file will be here. So it will access the HTML file. The HTML file in turn access the PHP, and it will read the SQL server and database, and you can control and see the status of the lamp. So this is simple, very simple idea. Actually, I am presenting this to understand the people who don't know what is IoT. So actually in the future section, definitely the experts will give you in-depth knowledge about that. This is to just remove the fear of IoT, and I want to show it is very simple. IoT development is not at all a bigger task. It is a matter of a day to learn. So then what is big in IoT? So big in IoT is we have discussed earlier, the research challenges, criticism, all these things we have to take care. Okay, so optimization, all these things are a matter. Developing the IoT system is not a matter. We need some basic knowledge about all these things, right? Writing embedded code using Python, writing HTML form, writing a PHP code, able to handle SQL server or database management. That is enough. Okay, and you should have an internet connectivity. Okay, so how to establish the connection? We know these are all the hardware is required. A lamp is we want to control the lamp, the relay, and this is a Raspberry Pi controller. This is a mediator between cloud and lamp. Actually, the cloud is the actual mediator. So it takes the data, store it in the cloud. So whoever wants to read the status or change the status, again they can go and read the cloud status and do that. So how to communicate? So this is the thing. First, we have to create the database and table in MSQL, MySQL. Actually, in the database, for each parameter, each load, you can create individual table. So by reading the table, we can understand the table content. Suppose you want to transfer the temperature. So you can store the temperature in the table, and where you want to read the temperature of different places, you can go and read it. Okay. So the create the database and table in MySQL is a first step. And second step is create HTML form to access the database. Third step is create PHP page to insert HTML form data in MySQL database. So PHP is used to read and write the data from or access the database, and HTML is a form to connect the PHP. So this is the three steps. If you know these three steps, IoT is nothing. Okay, this is software part. I have created very simple model. I just show you that, and the end of this FDP, our team will demonstrate you step by step in the last session how to create a model, hardware model, how to write the program, how to do the control, and you yourself can control the lamp in your place, and you can realize how IoT is, how simple it is. Okay. This is a database table. Actually, this is just I have used the 000 web host cloud. So here I have created table. My table is this. The database's name is test. In that I have created a table demo. The demo have the table have 4 columns: place, date, time, and temperature. So here I have this contain the name of the place, which date, and what time, what is the temperature. So like that, you can create a database. The database can be accessed through different means, right? So after completing this, I'll show you how to create the database, all these things if time permits. Okay, so this is a database table. So lot of that, not only 000 web host, lot of web host databases are available. And this is the HTML. So HTML file to access the database, connecting the database and PHP, we need a HTML file. So HTML file, actually here, yeah, this simple HTML file. This is my connect.php is a PHP. It is a post type. Okay, so connect.php is a PHP is used. I have all developed to connect the SQL. Okay, so when you run this HTML file, you can find just if you type that HTML address, you can find this. So what for this is developed is, if you give the location and submit the search button, if you submit the application, submit the form, so immediately it will go and access the PHP. Okay, so this is a HTML file. Many of you know that writing how to write the HTML file. Okay, so that HTML file produces this output. Next is, this is a PHP. So PHP is a mediator between MySQL database and HTML. So here, this is my table demo red. It is given in red color. So I am going to access this table. So where all the data are available, okay, and this is actually I embed the HTML code inside the PHP to display the image what is retrieved from the demo. Okay, so this is a PHP code. So this we will discuss in detail. I don't have time to explain how to write PHP code, HTML code, but it's very easy. Okay, so this is a PHP code. You see that if you run the PHP code by giving the location name as eRoad, it will give you date, all these things. Only one entry was there, so it gives this. Okay, so now we have accessed through HTML. This is user side. Suppose field device wants to access the database. How to do that? That is again simple. We don't want HTML. We can write Python programming at the controller side. Actually, this is a Python. Actually, I don't have hardware now. Just I'm showing an example. So how to connect a database and receive the data from the database. This is a Python code. So here I'm going to access the PHP code what is available in the cloud. Actually, this is Azure cloud. It is there. So status.php is my PHP file which is available there. Okay, so I'm going to open that file and read the data, and the data will be based on the data. I can know that whether the light is on or off. So if it is on, I'm going to write the light on. This is GPIO dot output comma port number comma true means if I true, the light will be on. Actually, this is to control a lamp, and false means it is off. So this is a simple Python program, send a single bit based on the data available in the database. If suppose user give the on information from outside, it will be read and we'll switch on the lamp. If it is off information available in the database, we'll read the status and switch off the device. So this is receiving the data from database. This is another thing. This is a sample program, Python program to write the data. Suppose I want to read some data through some ultrasonic sensor distance. So I can access the PHP file and the data can be stored into that variable. Then that will be stored into the database. So using Python, you can directly write a program. So this is the way you can access. From the field device, you can write not only Python, even simple C code itself enough to do that. What we required is a web accessibility. You should be able to access the URL. So other than this, there are cloud available meant for IoT itself. That is so simple. If you have an API code, you can directly connect that. Okay. This is just a simple setup. This is enough for a lamp on and off. This setup is enough, right? This is a Raspberry Pi microcontroller, and there is a Wi-Fi dongle connected with that, and relay lamp. So this will access the database. So database in turn we can access through mobile phone or whatever it is. Based on the input given from the mobile phone, the database content will change. So this will read the database content and it will give the instruction to relay, and relay in turn will switch on or switch off the lamp. So this is a simple IoT model, but complexity is concerned, it is zero. But why I have just showing this is, you know the IoT is so simple system, but there are a lot of opportunities to work. Okay, well, actually the initial video we have seen the smart home. You see how many sensors, how many data, how it is presented. That is a matter. Okay, so to first to start with, we can go like this. Okay, so we have come to the end of the thing. So skill required for developing this project is, one is a microcontroller or embedded system interfacing knowledge, and embedded programming, either C or Python or whatever it is. You have to program the controller to interface the field device and connect the cloud as well. And you should be able to write the PHP code to access the SQL database, and you should have an idea to how to create a HTML form for accessing through a web or internet, and you should have some knowledge about database management system. This is enough, but this is not a rocket science. It is matter of 2 days, 3 days to learn. Okay, but further getting into that, doing research, optimizing this is a matter. Okay, so I think the time is Yeah, I have 10 more minutes. I just show you how I can go to the uh, cloud and write the program, all these things. Simple, just a demo of that. Yeah, actually, Durga, is it visible, my web browser?
No, sir.
Now what you are seeing in the thing?
Sir, just your contact, sir.
Is it is it is it visible now?
No, sir, no.
It's visible, sir.
Yes, sir. Yes, sir.
One. Yeah, yeah, yeah. Actually, uh, this is so just going to already I have created a login because if I create a login it will take long time. So giving my email ID and password, I can get cloud. So 000 web host will provide you a free cloud also for a limited capacity of 300 MB like that.
Sir, it is not visible, your browser.
Oh, is it? Sorry, I think
Visible, sir. It's
visible.
visible.
Okay. Yeah, maybe it takes some time to stream. Okay.
Okay.
Now it has entered into that. So now I can write my HTML code, PHP code, all these things into this cloud. I can store all my code in the cloud itself. In that, I can go to my website, and in that you can find an option called as manage website. If you click the manage website, this is an example. There are a lot of other clouds are available, but there's no standardization. Different cloud behave different. In that, you can find two things. The tools, you can find file manager and database manager. So database manager, first let me show the database manager. Yeah. So this is a database manager. So if you want to create new database, you can create by clicking this, you can create a new database. I have created my own database, what I have shown in the presentation. If you click manage, you can open the server PHP my admin. This already I have created the database. Okay. This is test is my database name already I have given. In that, you can create number of tables. I have created only one table called as demo. You want more table, you can click new. So demo, I am going to open the database demo. You see that the place, date, time, temperature. I have created the table with 4 columns and I have entered just 2 entries, Coimbatore and Erode. Durga, is it visible? Can I proceed?
Yes, sir. You can
Yes, sir.
proceed, sir.
Okay. Yeah, the Coimbatore, the date is this, time is this, and temperature is this. So just I have entered 2 only for demo purpose. So now my database is available. So you can update the database through HTML and PHP, and we'll see the programs, how to upload your HTML file and PHP file in the cloud. For that, I can go here, go to File Manager. Then you can find upload files. If you click upload files, yeah. So actually you can find the folder public underscore HTML. So in that you can load all your HTML file, PHP file, everything. So once loaded, you can access it from actually this is my HTML file, what I have shown in what I have shown in my presentation. This is my HTML file. I have stored it. Then this is my PHP file, connect.php. I have stored it. Right. This is just to read the database. Okay. So let me just open this HTML file and see how it comes. Okay. So even you can check this. This is the ask_iot.000webhostapp.com is my website name. Even you can access from your place. So when I type this into the web browser, the website name is ask_iot. It's ask-iot. It's come. So when I run this thing, it will go and access the HTML file and it will ask for the location. So when I give the location name E-Road and when I submit the button, give the submit request, immediately it will go and access the data and it show what are the E-Road data available. So there is only one data, E-Road 29/2020. This is the data already available there, right? So actually there is another thing. You can enter the data also. That file also I have included, but I don't want to confuse you much. This is the idea. So simple. The creating a IoT is not a matter. You should be able to write a simple PHP file, HTML file, and you should be able to write a Python coding in your Raspberry Pi controller or C coding if other controllers are there. Okay, so this is all about. So creating Internet of Things is such a easy matter. Even according to me, even 12th standard students can do that. So doing next level research, doing next level standardization is a matter. This is our work. So what is required is that also. Okay. So with this, I like to conclude my speech. I thank all the participants for your passion listening. Yeah.
Thank you, sir.
Thank you. Any questions?
Thank you,
Please
sir.
feel free to ask. Yeah, if you have any doubt or question, I'm ready to ask. Ready to clarify.
So, participants, you can ask your questions.
Or otherwise, end of the day also you
You
can.
can post your questions in the chat box also. It will be
Yeah.
answered later.
Okay. Thank you very much. So next session will start at 11:30. So please join again at 11:30. Thank you. Thank you very much. Durga, thank you for coordinating. Thank you.
So thank you, sir, for your informative session, sir. It's really a lighting up session for introduction to IoT, sir. So participants will have an idea about IoT now, sir. Thank you once again, sir.
So please, all of you join at 11:30 sharp. The guest will join by 11:25 itself. Thank you.
Yes. Thank you, sir.
The participants are requested to join at 11:20 a.m. The next session starts at 11:30. So please short. Thank you.